Hi, this is Mr. Roche. We're back with the floating square, and we need to get the square to go up and down as opposed to right and left. Okay, so the way you do that is what I would do is I would set the x speed in this case again to 0. Okay, and I'd set the y speed to 5, so we get it to move up and down. So right now there's nothing stopping it from going up and down. Right, it just goes away. And then what I'm going to look at is I'm going to look at the going up and down speed, okay? So what we want to know is if it's like what's happening right now is if it's positive it goes down, okay? So what we're going to do is for going down we're going to do this and go if x speed s is greater than 0, then it's going down. That's what it means, okay? And so then what we have to do is we have to sort of check and see if the speed, if the y speed is greater than the screen height, and we'll throw in that radius s divided by 2 stuff, okay, to handle that. If that's true, then what I want to do is I want to keep it on the screen, so I'll say ys equals screen h minus, and we'll throw in that r. Whoa, I don't want to do that. We'll throw in that rad stuff again. I don't know how that happened. Call it rad s divided by 2. Okay, and then we'll flip the y speed. So we'll say y speed s times equals -1. Okay. And then we'll do one more for going up, okay? So we'll look at that. So let's test this out now. Okay, so here we go. We're going down, we're going down, we're going down, going down, going down, and boom. Oh, we didn't stop. So wait a second. So wait a second. If we're going down, let me see. So y speed is 5, so it's positive, right? So if ys is greater than screen height, let's see why it didn't work. Oh, maybe we didn't save it or something like that. Okay, sorry, it didn't, I'm looking at it, it's still not working, but I think it's not working because we made a mistake. And there, it's got to be y speed, so let's try that. Okay, so you got to be careful with all your units, okay, that's the thing. This is sort of one of these things where you need to be careful. Okay, let's try it again, here we go. It's going down, going down, going down, going down, and bouncing. That's good. Okay, so now it's going up, and it's going up, and it's going up, and it's going up, and it's going to not work until we get the code in here. So we're going to say if y speed s, and we got the right y, is less than 0, which means it's going up, okay? That's right. And then we'll check the coordinate for this. So we'll go here. Okay, watch out for the colon. We'll say if ys is less than, it's going to be just rad s divided by 2. If that's true, then we're going to set y speed, or the y coordinate to be equal to rad s divided by 2. And we'll flip the y speed again. We'll say y. So each time, for all 4 corners, you get the y speed s is flipped. Okay. -1. Okay, and we'll see if that happens. Let's see if that works. So it goes boom, and keep going, keep going, keep going, keep going, keep going, and boom. And that's great. Okay. So if that's true, and everything works, so what's going to happen is you're going to have 4 if-thens for boundary control. Okay, see all this? This is a big deal, right? Okay, so then what we want to do then is we can, since we're sure this is working now, and we have random working for us here, we can set these to random numbers. We can say rand int, I don't know, something from like let's say like 5 to 10. Okay, and let that happen. That might be too fast, but we'll say okay. And we'll do that. And see, now you can get it to go in 2 directions. You can watch what it does. See, it'll bounce around. It should just sort of do its own thing. And that's good. See what it's doing? That's good. Boom, boom. And that's nice. Okay, we really like that. Okay, but what I also wanted to do is I wanted to slow it down by the friction factor. Okay, so this is like the last part of this. Okay, we want to get this to happen, and we want this to work sort of for air hockey or whatever. So what I've got is I got my friend here, the friction factor, and what I'm going to do is at the end of all of this, okay, I'm going to kind of slow it down by the friction factor. Okay, and I'm going to go like this, and I'm going to say, let's see. I guess I could do it here before I draw everything too. I could say y speed. Let's see. I can say if it's doing this, working on figuring out the friction factor. So this is how it slows down. So we're working on slowing down because of the friction. Okay, and here's what we do. Okay, so I think what you got to do is you got to check out like whatever the speed is. I guess we'll have to have 4 of them. So we're going to say if, let me see. I guess we could probably add it into here too, actually, because if the speed's going bigger, right? We could do it like here maybe. No, let's just do it. Let's do its own thing. Okay, so we'll do it. We'll have a separate thing for it. We'll say if x speed s is greater than 0, then what we need to do is have the x speed s slowed down a little bit by the friction factor. Okay, so let's test this out. Okay, so what we'll do is we'll set the y speed to be 0 right now. Okay, we'll let the other one be random. So what it'll do is it'll sort of go like this. So see what it's doing? See how it slows down? Okay, that's good, right? And just to be safe, what I want to do is I want to go, when I'm doing this, if I go x speed, just so there's no extra problem if it's less than 0 here in this case, I want it to be x, I want it to actually stop so it won't like wiggle around. Equals 0. Okay, so let's try that again. Whoopie, whoop. Do wrong here. Oh, I have to say if. Okay, so here we go. So here it goes. See, it'll stop. And I don't want it to go backwards or anything like that either. Okay, so that's good. So that handles that one. And I'm going to say if x speed s is less than 0, meaning it goes the other way, what we'll do is we'll do the same thing, but we'll kind of add it by the speed factor. Okay, and then we'll do a check on this too. We'll say if x speed s is greater than 0 for some reason, from after this kind of speed check thing, we will make the x speed s equal to 0. Okay, so that's good. And so let's try this with some bigger numbers here. Instead of random int, I'm going to make this be like -10, and hopefully it'll sort of stop. So there it bounces. Okay. Let's make it. Let's make it go +10 too, so we know that it bounces and stops. And there it goes. I think it's going to be fine. Okay, so I can make it like 15 or something. Let's try that. So I want to stop. Stop. See what it's doing? That's good. And I'll make it -15 too, see what happens. So it's going the other way. Yeah, it went too far. Okay, but this is working. It seems okay. Okay, so then we got to do the same thing for y, okay? So, let's see. So, we need 2 more for y. So we're going to go if y speed s is greater than 0. So they're the exact same thing. We'll say y speed s minus equals the friction factor, and then we'll see if it gets too far. We'll say if y speed s is less than 0, we'll make it be 0 equals 0. Okay, and then one more, last one. Let's say if you can even copy this one. Okay, done. Let's say if y speed s is bigger, less than 0. And we'll say y speed s is, you add the friction factor to it, and if y speed there, and then if it's bigger than 0, then we have to stop it automatically, and then we'll give this a try. So what we'll do is we'll make x speed s be this, we'll make this be 10, and we'll see what happens. So there it goes, there it goes, there it goes, and hopefully this is going to stop for us. Okay, let's try a negative 10 with it, see what happens. I think it's actually okay. So we'll see what happens. Okay, so let's put some random numbers in here. Again, let's say rand int from 0 to 15 maybe. And we'll say, or we'll say we could make it go negative too. We'll say negative 15 to 15. Let's see if this works. And hopefully it'll just sort of look like a bouncing thing. So here it goes. That seems okay. That seems okay. That seems okay. This is just what we wanted to do. We wanted to kind of like walk around like a sort of a hockey puck on an air hockey table. Okay, that looks good. Get some good situations here. It doesn't look unnatural. That's the point. And you can try other numbers if you want. You could try bigger ones. You could try like 20 and 20. Don't want to get too fast because of the drawing capabilities, but it can take a lot, I think. Here we go. Let's run it again. I think it's fine. That wasn't very good. That wasn't very good. That's better. That's better. That's kind of what we're looking for. That seems good. Okay. So anyway, guys, that's it. Okay, I want to get this built. I want to see it, and here's what I want for homework: is I want you to make a 1-minute video that shows your code and also shows the how it works. Okay, so if you want to test it out and run it a couple times to show me that it's working, that's good. If it's not working, I want you to explain why it's not working. Okay, so I need a video here. A minute video is fine. You can just sort of run through the code. I can take a look at it. Okay. But I need to see a video rather than the code on this one, because we're going to keep working on it and the code's going to change and stuff. So in the end, also make sure you save your work, okay, and just be proud and happy about it. Talk to you later.